This paper, Chain of Thought Reasoning Without Prompting. If you are conversant with the current development in the large language model, you know that prompting has been the de facto way for you to be able to elicit reasoning from your large language models. Without that, your large language model will fail to be able to perform certain reasoning tasks effectively. But this paper is claiming that in using your large language model, you don't even need any prompting at all. You know, the reason why we use prompting is we want to kind of guide the large language model into the answer such that it kind of figure out the reasoning before it arrives its answer. So at its answer. So this paper says that inherently in the large language model decoding steps, this reasoning that we are trying to kind of elicit with prompting or chain of thought prompting, it's already inherently there, that we don't even at all need prompting or even asking it to do any chain of thought. That all we need to do is to inspect some steps in the decoding steps, and we will inherently see the chain of thought. For instance, if we look at this figure 1, we do have a question sent into the model, and there's nothing like prompting here. We are not asking it to think step by step. There's nothing like few shot. So we're just giving it the question, and that's all. And in the decoding step at step 0, you could see that there are different pathways. Here they are showing 1 to 5 through which the model can arrive at its answer. Now they show us there that if we continue the greedy decoding, you will see that the model just gives you an answer without reasoning. But if you drill down into the alternative, the other steps, you'll be able to see that the model actually has a chain of thought reasoning in its part. So that is what is shown in table 1. So if you look at this table 1, you will see the two examples here. When k is equal to 0, that is the greatest step. But when you explore the alternative top k part, you will discover that you actually see what a chain of thought reasoning, the model actually explaining its reasoning before it arrives at the answer in these scenarios. Okay, and the same thing in the second example here. Another important thing they mentioned in the paper here is that the model also gives you a confidence as to how sure it is on the answer, and that confidence is always higher in the decoding part that actually elicits the chain of thought reasoning. Very interesting work. You see here it's 0.978, and they claim that the chain of thought decoding part is agnostics of the kind of models or the kind of the model sizes. And they showed here how you can actually calculate the confidence score of the model. So they showed us this formula here for calculating the confidence score of the models. When you examine the logic, you find that the chain of thought part always leads to more confidence, that is higher probability in the final answer. So very interesting work here. So they said irrespective of scales, they see the chain of thought. Irrespective of models, they see the chain of thought decoding part. And they experimented with PAM2, Mistra, and Gemma here. One last thing is that they experimented with only branching at the first token. So that is when you have the first token, you can branch, the second token, the third, you can branch, but the experimentation is only on branching at the first token, and it will be good to explore branching at other tokens. One challenge with the problem limitation is that it's resource intensive because you have to explore the other alternative decoding part, and that can incur some additional cost on that. All right, that's it for now. Thank you very much, and see you in the next one.